All right, this is 6th grade Excel lesson 70. This is a pretty tricky one, some new ideas on statistics today. What we're going to be learning is recognizing the difference between probability and statistics, defining dependent and independent variables, central tendency, statistics, and outliers, recognizing factors that influence data collection, and creating a scatter plot. Lots of things to learn on this lesson, so you might want to rewind, watch over and over again so you can get this down really well. Let's go ahead and start reading here. Joel needed to know if there was a relationship between a student's age and the time spent on homework each week. Joel's school is very large. Instead of asking everyone, he decided to ask 10 students in each grade. His results are shown on a scatter plot, a type of chart which places each point on a grid to illustrate relationships between two variables. In this case, the variables, are study time and student age. So we're going to go over this chart here. I'm going to explain it to you and help you to understand what a variable is. So a variable is something that can change. The word vary means to change. And what you're looking at here is a scatter plot of study time by age. So down at the bottom we have some labels on here that will help you to understand. Change colors here. Come on. Okay. So down at the bottom of the chart it says it's student age. So you can see this 6 here represents 6 years old, and over to the far right 13 years old. That's a variable. That's something that changes over time. And then on the side here we have average study time in hours. And so the 1 is 1 hour, the 12 up at the top, 12 hours for the average study time. Now let's take a look at some of the dots on here. If you look at this dot right here, what that dot means is that was one student that he asked how much time they studied and how much time they did homework. And this student is exactly 9 years old. How much time did they study? That student studied for 5 hours. It says 5 hours, and I believe that's per week. Yes, 5 hours per week. This dot right here, give you another idea, comes straight down. That student is 10 years old, and if you follow the dot over to the side exactly where it is, the 8 is right here, the 9 is right there, so halfway between 8 and 9, that would be 8.5 hours, and this is actually halfway between 8.5 and 9, which means that would be 8 hours and 45 minutes, halfway between 8.5 hours and 9 hours. So this single student right here that's 10 years old studied for 8 hours, an average of 8 hours and 45 minutes per week. Let me get that cleared off. Okay, so this is a scatter plot, and each one of these dots represents a different person that he asked how much time they studied. Let's go to the next page. It says Joel is trying to determine if time spent studying, that's called the dependent variable, is affected by the student's age, the independent variable. The central tendency is the numerical average, or the center of a set of values. So we're going to go back to the chart here again. Take a look at this. Joel is trying to figure out if the dependent variable is the amount of time that they spend studying. And what that means, and this is the independent variable, their student age. Their age is going to change no matter what. It's completely independent. This number is dependent upon that number right there. Their age does not depend on how much time they study. How much time they study depends on their age. Think of it this way. If you wanted to become older, do you study longer? In other words, hey, I don't like being 8 years old. I want to be 10 years old, so I'm going to study a longer amount of time and then I'll be 10 years old. No, that's not how it works. So you can see that the student age is independent. It doesn't rely, it doesn't need the study time to change it, to change the age. However, when you look at it the other way around, it makes a little bit more sense. If you are 7, the amount of time you study is going to be different from the amount of time that you would study if you were 12. And so the study time depends on how old you are. Your age does not depend on how much time you study. It's very difficult. Hopefully you can get that. I'm going to have to go ahead and move on. And, the other thing that they explained there was the idea of central tendency. Central tendency, by looking at this chart, is all the people right in through here. They tend, a 7-year-old tends to study about this much time here. A 9-year-old tends to study somewhere in there, about this much time. And so the central tendency means where does it tend to be in the center of the data, or kind of the idea of an average. Statistics involves analysis and interpretation of numerical information, which we call data or data, that has been collected from a sample or population. This differs from probability, which is the likelihood of an event occurring or not occurring. So let's make sure we understand these two terms. Statistics is what we're looking at on this scatter plot, where we're taking information, we're taking numbers from like a questionnaire or a sample, and we're analyzing them, we're thinking about them, we're saying what we think they mean. And whereas probability is how likely something might or might not happen. So when I roll a dice, what's the chance that I'm going to get a 2 on the dice? That is probability, not statistics. All right, so what did Joel learn from the data he collected? So we go back and we look at the chart, and from looking at this, what can he learn? Go ahead and write down a sentence that explains what you think Joel could find out by looking at these individuals that he surveyed. What information does that give him about study time? Write that down, pause the video, and then start it up when you're ready to see the answer. Okay, what that would tell him is that the older a student becomes, something like this. Your wording doesn't have to be exactly the same. The more, a lot of people would put they, but it's actually he or she studies. Or something like older students study more than younger students, or something like that. Now, you shouldn't be copying what I wrote here. You should just have written your own answer down, and then after you write it, check out and see what my answer is, and hopefully learn from that. This is, remember, a lesson. You're trying to learn something here. This is not a test. Okay, the next question says, 2 data points are labeled as outliers because they are far removed from the rest of the data. Can you identify them? How might these points influence Joel's conclusions? So there's 2 points that are not really part of the central tendency. Take your pencil right now and circle those 2 points. Pause the video for a second and then turn it back on. Okay, the 2 points that you should have circled, hopefully you've already circled them, are here and here. Those are the 2 outliers. That's an outlier, that's an outlier. Think of it this way, it's lying out of the central tendency. It's lying out there and lying out here. Not very close to the other numbers. And then it says, how might these points influence Joel's conclusions? What can he tell about his data because of these 2 kids that are out here? Go ahead and write a sentence, make your best guess. I know this is a hard question. Pause the video and then start it up again to see what my answer is. Okay, these 2 outliers tell him that he has 2 students do not spend a normal amount of time studying. You see, these two people here are outside of the normal range. The normal range is right in here. So the other thing that it might influence his conclusions, a conclusion is what he's learning from this set of data, his statistics, is that they could influence or change Joel's averages, or his average. So if he was to calculate an average for, say, kids that are 12 years old, kids all along here would be 12, because once they get to here, they're 13. So if you found all these points along there, this kid right here that studies hardly any time for a 12-year-old is really going to mess up the average, basically, is what's going to happen. It's going to bring the average way down. This kid right here is really going to change the average for 6-year-olds, because these numbers in this, let me clear this off, it's getting kind of hard to see. The numbers in here are the 6-year-old kids. And look at this one 6-year-old studies for 5 hours, the rest of them are studying for hardly any time down here. So this one kid is going to bring the average way up. It might be a good idea if he just got rid of these two kids and didn't even consider them when he was figuring out averages. Next question says, because Joel only asked 10 students in each grade, what factors could be influencing his data? What information would be helpful in determining the validity or the truthfulness, the accuracy, how right it is of his conclusions? So you might have to read that question again, give your best shot on writing an answer, pause the video and turn it back on to see what my answer is. Okay, the things that could influence the validity of his conclusions are things like, let's see, if he ask only his friends to answer the question? That could change whether those numbers are right. Did the students give accurate answers? Are they just making up how much time they study? And so on. So there's different things that can change how his data comes out. I'm going to show you some different answers in just a second as well. And then the next question says, what other methods could Joel have used to collect his data? So go ahead and write an answer, pause the video. Okay, the other ways that he could do it is he could have like maybe a discussion with a group of people talking about how much time they studied. Another thing that he could do would be to ask the parents instead of asking the kids. And another one would be observation. And that means watching people and seeing how long they study. So that's it. Let me put up these answers that are given here. You might want to just pause the video on those and read those over. Thanks for watching.